Focusing on square and square root, we are given the following question, which says that given the following image as shown right over here below, determine the square and square root. What I'm going to do is pause this video and check this image out, see what the relationships between the lines and the space relates to the square and square root. And once you're done, you can play this video and we can dive into what these two concepts mean and how they relate to each other. So let's begin. First is making connections between multiplication table and square root. We realize that we are given factors multiplied by factors and we are asked to fill out this multiplication table, and most importantly we're going to be watching out for a pattern that makes an interesting relationship between the multiplication table and the square root. But first we're going to focus on squares, and what we see is the following. When we are multiplying or observing our multiplication table, the trend that we're going to be looking at is a diagonal trend, and this diagonal trend is going to show the following. The result when you multiply the same factors together, and what we see is multiplying 2 by 2, that gives us what? 4. And next is 3 times 3 gives us 9, 4 times 4 gives 16, 5 times 5 gives us 25, 6 times 6 36, 7 times 7 49, 8 times 8 64, 9 times 9 81, and finally 10 times 10 is 100. We can continue all the way on the row, increasing numbers as well as that of this column. From our multiplication table going now to our square, we are going to observe that from the multiplication table we can transform this observation here in power form. And what does that mean? That means that when we concluded that multiplying the same factors by itself, we are going to have a result that is looking like a power form, and this power form is going to later lead us to the final answer. And the power form shows us that the same factor number to the exponent of what? How many of them are there? Which means we have 2 of the same factors that you're multiplying together, and that 2 that we have here represents what? It represents the square of your same factor. And therefore, for example, if we have 2 times 2, that gives us what? We have what is repeating. We have 2, we put it as our base, and this our base here tells us what is repeating, and we are going to address this or make connections to the original question. And next is how many of these same factors are you multiplying by itself, which means that you're going to have 2 of them, which represented as our exponent. And once you're able to realize that, then we can move on to other examples of this. Like for example, what is the square of the given numbers? In this case, for A we're given 11, and for B you're given 2 divided by 5, or 2 over 5. For the first one, what we see is that yes, we know that we're given the number to be 11. That means that our given number, which is 11, we're going to apply the square, which we highlight here to be what? Exponent. And so the exponent is represented as the square of the base. And therefore, once you realize that, we can put our exponent to be what? 2. And so once we put our exponents to be 2, this means that you have 2 11s that you are multiplying together. And therefore, once you have this written as 11 times 11, our answer is what? Going to be 121. And so this is what I mean when you ask to find the square of a given number. That means a given number is the base. We know that square is the exponent 2. And the same thing is applicable for b. And for b, you're given the number which is 2 over 5. And this means that we are going to perform the square, and we know that this square is exponent 2 of this number, and therefore once we apply our square to this number, we are going to move on to the solution, which means that we have 2 of these fractions that you're multiplying together, and what that looks like is 2 over 5 times 2 over 5. And what this means now is you can now solve this problem. Remember that this here is the same thing as what multiplying the numerators together, and this looks like 2 times 2 over, you have the denominator which you're going to multiply together, which means 5 times 5, and that gives us what? 2 times 2 gives you 4 over 5 times 5 gives us 25. Next is when relates to a shape, we observe that a square is used to make this relationship to be properly visible, and this implies the following: that in a square we know that all sides length are equal, and this is shown with a single tick mark, and this length that is equal for side length can reveal a lot of things about the square. This shows that yes, when the length, in this case as shown right here, multiplied by the width, which is shown right here represented as W, when we multiply them together, this shows us that it gives us the area, and the area of a square, when we dive in details on what value is the length and the width, we know that the length is equal to the width. Therefore, this shows that yes, the side length multiplied by the side length, this is equal to the area, and the area of the square is the space that the square covers. And then when we see this established, we can now simplify this expression in the form of a power form, and simplifying this to a power form looks like this, where we have our side length times side length, which is what? Shown as side length. How many of them? 2, which means that our exponent is going to be 2, and this implies that the side length is represented as the base, because that is what is repeating. And how many of the side length are you multiplying? We have 2 side length, and this 2 is represented as the exponent, and therefore the exponent is also stated to be what? Squared. And so once we apply the squared to the side length, that means that I'm applying 2 as exponent to the side length, which is the base, and that will give us the area. Now for an example, given length of a square to be 4 units long, what is the area of the shape? And in here we are defining the shape to be what? The square, which means that for solution we should expect a square to be analyzed. And from what we understand about a square, we know that all side lengths are equal. And once we are able to understand that, we know that a given side, which length is whatever value is given to be 4 units, we expect that the other sides as well to be measured 4 units. We can now establish this relationship to be in terms of what is the area of the shape. So we are going to multiply our side length by our side length, and this shows us that it's going to give us the area, and therefore this here is equal to what? We have the side length to be 4 times 4, which is this other length side, and therefore when we express this as power form, we know that we have what is repeating. We have 4 to be repeating, and what is the exponent, which means how many 4s are you multiplying. We have 1, 2, and we are going to write R2 as the exponent. So what does this mean? This means that R4 is represented as the base always, or it is with respect to the square, the side length of the squared. That is always something to remember. The base is always the side length of a square, and while the exponent, which is 2, symbolizes what? Exponent, which is represented as the squared 2, always applied to the base, which is the side length, will give us what? The area of the squared. Therefore, our answer is what? 4 times 4 equals 4 squared, which is finally equal to what? Equal to 16. And therefore, the space that is covered by this shape is measured to be equal to what? 16. And that is something to remember when it comes to relationship between the length and the area of a square. Take note that this here needs a unit, and the unit for this is what? We have 16 square units. And so what does that look like? This looks like the pictorial design that we have right here, which tells us that pictorically, when we are diving into how many units are in the big square, and this implies that by dividing this into the following, which we know to be 4 units, while at the other side, which is right below the base, we have 4 units. Therefore, we can draw 3 lines vertically and 3 lines horizontally. Therefore, when we count the number of unit squares, it means that one space inside is called a unit square. We can, or a squared unit, we can now determine how many square units we have inside this squared, and this implies that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This pictorial form shows us that we have 16 square units, which is also represented as the area of the squared pictorically. Focusing on square root, we understand that this is indeed the reverse of the function squared. And what does this imply? This implies that when you're asking yourself the question for square root, we need to realize that we need to say that what same factor will you or will I multiply by itself. And once you're able to ask yourself this question, you should be able to address the solution to the square root of a number. One more thing to remember is in terms of the symbol. You can find this symbol on your calculator, and this symbol is not a division symbol because for long division we have this symbol to be shown as this, or sometimes this curved label. So that is something to remember in terms of differentiating between these two symbols from this sharp symbol right here. Note that the number of focus is assigned in this space right here, and therefore if I'm asking you what is the square root of a number, that number is going to be placed in here, and by applying the square root you'll be able to determine what same factor will you multiply by itself. And this example comes into play where we need to find what is the square root of the following numbers. For A, we are asked to find the square root of the number 9. What this means is that we are going to apply the square root, which is for our solution we show the symbol and then you put the number in question, which is 9, inside it. And once you're able to do this, the question that you should ask yourself is, what is the same factor that I multiply by itself to give me the square root of 9? And to do this, all you do is look through your multiplication table and you should find one factor that is able to be multiplied by itself, which is 3 indeed times 3. Therefore, our final answer for the square root of 9 is equal to what? The same factor, which is 3. For other situations, you will be having two answers, but for this case here, we're going to be showing only the positive value of that same factor, not the negative value of the same factor. And so that is our answer to this question. The other one here is when you're given the number 81 and you're asked to find the square root. Remember, the solution is we're going to show the square root symbol and apply the square root to the number 81, which means we are finding the same factor that we are multiplying by itself. And once you're able to look through your multiplication table, you should be able to arrive at the number 9, which means if I multiply 9 by itself, I should be able to have therefore the square root of 81 to be equal to what? 9. And remember, I'm using the positive value of 9, not the negative value. And so this is how you're able to establish square root given a number, and we're going to look at how this applies to the square shape. For the applications of a square root, we're going to focus on the shape, which is a 2D squared shape. And this shape shows that there is a relationship between the area of the square, which is the space that this two-dimensional shape occupies, and that of the side length. And what we realize is that when you have the area of your square, we are going to look for a way to determine the side length of the same squared. And to determine the side length of the squared from the area, which is right here represented as A for area versus this here, which represents the side length, we need to perform a function to the area of the squared, and the function that we're going to apply here is what? The square root. And the square root of the area of the squared will give us the side length of the squared. And this here implies that all you need is the number inside this function for square root, and the number that's inside indeed represents the area of the squared. And once you apply the square root, we are going to determine the side length of the squared. And this is going to be shown using this example right below, where given the area of a square to be 16 square units, we are going to draw a square, and this is measured in terms of the area to be equal to 16 square units. And once we have this highlighted, what is the side length, which is going to be represented as here? Remember that the length of all sides are equal, as shown using this single ticks. And what that implies is that whatever answer we determine here is the same number for this side, the same for this side, and same for this side. And now the solution to this question is as follows. We know that the area of a square, once we apply the square root function, that gives us the side length of the shape. And therefore, since we know that the area of this squared is equal to 16, we're going to write 16, apply the square root function, and that means we are looking for the same factor that we multiply by itself to give what? 16. And so by looking through your multiplication table, we figured that yes, indeed, 4 times 4 is equal to 16. Therefore, our answer to the square root of 16 is the same factor, which is 4 units is our answer, which is what? The side length of a squared. On the other hand, using another method, using pictorial, we need to be able to address this question. When we are given the area of the square to be 16 square units, we are going to determine the side length of that square. To accomplish this, we need to develop a squared space in such a way that we are going to have our area to be 16 square units inside it. And in order for we to pull this off, we need to draw lines that are equal to not only the horizontal, which shows that yes, if I draw 3 lines, horizontal lines, and we have 3 vertical lines, we can now arrive at a solution which we assume, although each spaces doesn't look like it's equal to 1 square unit, we can see that yes, when we have this counted, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16 square units inside it. Therefore, we need to focus now on how many of the spaces are present on each side. And we need to confirm that they all must be equal to each other. And what we see is that on the width side, we realize that yes, the side spaces is 1, 2, 3, 4. Likewise, on the other side, which is the length, 1, 2, 3, 4. Therefore, we can see or say that in conclusion, the side length here is equal to 4 units. Then we have our answer from 16 square units to be 4 units on each side of the square. And our answer here is what? In here, our square root of 16 is equal to what? 4 units. So this is another way to be able to accomplish this solution using pictorial method. I hope you found this really informative in terms of understanding how square root works and also how to apply it, and finally determining what a square of an object is and how to apply it to different scenarios, and going back on how the relationship between the multiplication table relates to our understanding of a square, and how we can use the pictorial graph or grid to be able to determine not only the square of an object, but also you can determine the square root if you find that really informative. All the same, thanks for following us through this. Truly appreciate it. See you all on the next one. Stay smart as always and believe in yourselves.